in order to simplify radical expressions, we use these two properties in red on the right here. And I'll just describe this first property. This is really the main driver of everything that we're going to do. What this says is to take the nth root of an exponential expression, you divide the exponent by the index. So a quick example here, let's say if we're asked to find the third root of a to the 12th, that would be a to the 4th. That's what that property is describing. It's saying what you would do is you would take that exponent of 12 and you divide it by the index right here to actually take the root. This second property here is really important and helps us in support of that first property. It says we can split a radical over multiplication. And I'll show kind of how we attack that with this problem right here. The first move I would do is to find the prime factorization of your number, in this case 64. 64 ends up being 2 to the 6th power, so I'm going to rewrite that. The reason for using prime factorization is it's going to allow us to deal with the numbers and all the variables in exactly the same way. Alright, the second step is I'm going to split up this a to the 11th into two factors that have to equal a to the 11th. I want one of these factors to have an exponent that's the largest multiple of 3, in this case 9. So I'm going to rewrite a to the 11th as a to the 9th times a squared. Alright, now what I have, these first two factors, the 2 to the 6th and a to the 9th, have exponents that are multiples of our index of 3 and are going to work nicely with that index. This other factor, a squared, is just necessary because we had 11 a's to begin with, and it's really the remainder after I found the biggest multiple of 3. What I'm going to do is now employ this property over here where I can split the radical over multiplication, and I'm going to split it between these two groups that I have. Alright, and again, what I have is my first group split over this cube root. These are the things that are going to work really nicely with the cube root, and this a squared over here is just the remainder of that a to the 11th. Now what I'm going to do is I'm going to take the cube root of the stuff in this left radical. To perform the cube root, what I'm going to do is to divide these exponents by the 3. And again, I've split apart so both of these will work well with dividing the exponents by 3. So I divide the 2 to the 6th, I divide the exponent by 3 to get 2 squared. And the a to the 9th become an a to the 3rd. I don't have the radical anymore because I performed the radical on these factors. But I still have the cube root of a squared over here. My only last step now is to simplify what I have taken out here. 2 squared is a 4, then I have an a to the 3rd, and then I have this stuff left, the cube root of a squared. Now that is the complete process for simplifying this radical expression. And just for a second to speak to how to answer this with WAMAP, what they're asking is the stuff on the outside of the radical becomes the a, so this 4a cubed, and the stuff under the radical here becomes the b, which is a squared. And so in answering this problem, 4a cubed becomes my a value, that's the stuff on the outside, and the stuff on the inside is this a squared.